Now let's move to deterministic model. Our aim is to determine when to order and how much to order. And we have to make this decision with some economic considerations. Here we will try to minimize the cost, so we need to take into account inventory related costs. We have holding cost, ordering cost, purchase cost, shortage cost. But here in this model we will only consider holding costs and ordering costs. The inventory holding cost, or this is the cost that we need to pay per unit of the product that is held in inventory. This is it can be considered as or perceived as the opportunity cost, because the capital is tied in the inventory, while it could be invested in some other stuff. And then we have ordering cost, which is the administrative cost for making orders, and so on. So we have here two cost terms. Now let's see one example. Here we have the demand for one item, which is everything is deterministic. First, let's emphasize that. So we have deterministic demand. We assume that the lead time is equal to 0, and we assume that the back order is not allowed. In fact, if we make the right decisions, so we will need to go into back orders at all. Let's see what will happen if we consider an order quantity equal to 400. If we have an order quantity equal to 400, then to satisfy a 1600 units of demand per year, we need to make 4 orders. 4 multiplied by 400 will give us 1600. When we have a order of size 400, then we will make orders less often, only 4 times per year. So each time if we make an order, we will pay ordering cost, fixed ordering cost. And then for an order of size 400, we have an average inventory level equal to 200 over 1 year. And we need to pay an inventory holding cost per unit of this average inventory that we have. Now assume another scenario in which we make orders of size 100. Then we need to make 16 orders per year in order to be able to satisfy demand equal to 1600. This is the red curve that you can see. And of course we can see that orders are made more often, so we are paying the ordering cost more often. On the other hand, we have a lower average inventory level, so the inventory holding cost is lower in this case. So we have two different costs, and we want to make a trade-off between these two different costs. We have inventory holding cost, which is higher in plan A and lower in plan B, and ordering cost, which is higher in plan B and lower in plan A. Here we see the notation. Let's D denote the total demand per year, S be the cost to place a single order or fixed ordering cost, and H to be the cost to hold 1 unit of inventory per unit of time, which is a year in this case. And then we have Q as our order quantity. The total cost then will be the yearly holding cost plus yearly ordering cost. What is the holding cost? The holding cost is the unit inventory holding cost H multiplied by the average inventory level, which is Q over 2 for what we saw in the previous slide. And the ordering cost is simply the ordering cost for a single order, which is S, multiplied by the number of orders that we make each year. And it is equal to the demand multiplied by the order quantity. So if we have a demand of 1,600 and we make orders of size 400, then we will have 4 orders, and for each of these orders we will pay the cost S. We can plot these different curves based on Q, taking Q as the variable, so we can see for different Qs how these cost terms will look like. We have the red line, which is a linear line with respect to Q. As you can see, it is H over 2 multiplied by Q, so it is linear in Q, which is the inventory holding cost. And then we have this decreasing curve, which is the ordering cost. And then we have the total cost, which is first decreasing and then increasing. In fact, if we take the first derivative of the total cost with respect to Q and then solve it for Q, put it equal to 0 and solve it for Q, then the optimal order quantity will equal to the square root of 2 times D times S over H, which is called economic order quantity or EOQ point. This is the optimal order quantity to make each time that we are making an order. And the point is that at this economic order quantity, 2 cost terms, I mean the inventory holding cost and ordering cost, are equal to each other. I mean the time that these the quantity at which these 2 curves cross each other is exactly the Q at which the total cost reaches its minimum. So we answered the first question, which was how much to order. So we found Q star, economic order quantity. The next question is when to order. And when we have deterministic lead time and demand, then it is easy to know exactly when we want to make an order. And then in this case, the reorder point is the total demand, is the point at which the point of time at which the inventory is equal to reorder point. And what is this reorder point? It is the total demand during the lead time. And the lead time is the time between placement of an order and its receipt. So if we have L units of time as our lead time, so if the lead time is L, and we know that for each units of this time, demand is equal to D, then reorder point is simply D times L. So if we have a lead time equal to 2 weeks, and if we know that weekly demand is equal to D, then reorder point is equal to 2 times D, which is the weekly demand. The important point is here that we need to have the same time units. So if the lead time is 2 weeks, then you cannot use the yearly demand here. So you need to convert it to weekly demand and then use it in this formula.